So, we are complete. Thanks for joining us, Brinja. So this this panel's topic is about building bridges in the Interchain and beyond. And before we dive deeper into the conversation, just want to announce my awesome guests on this panel today. So again, on my left, I have Brinja from Composable Finance. Then, of course, Arnaud Delabarre. Sorry, my French sucks.
It's Odysseas.
Hmm?
we had a change in the panel.
Okay.
So it's Odysseas, yeah.
Okay. Yes. You're from Nomad, but then Rahul, Sethuram from Connext, and of course Peter Kim from Polymer. So, and before we dive deeper, it would be super cool if you all could give us a brief introduction about your project. So maybe you want to start, Ranger?
Sure. So Composable is focused on essentially creating a orchestration layer for cross-chain applications by tapping into trustless bridges such as IBC to create higher order logic for applications that are intended to become kind of blockchain agnostic, but first and foremost focused on sort of multifunctional in use.
Hello, everyone. Nomad is a generalized protocol for passing arbitrary data between chains or domains. And it falls to the optimistic family of designs, which makes it very lean and very simple and elegant.
Yeah, hi everyone. My name is Rahul. I'm one of the co-founders of Connext. So Connext is basically a decentralized liquidity layer. We've built a couple different versions of cross-chain bridges in the past, built on state channels, atomic swaps, and our most recent upgrade is going to be built on top of Nomad. So using Nomad as the low-level message passing interface, and we handle all the liquidity as well as kind of like interface for passing messages cross-chains.
Hello, everyone. My name is Peter Kim. I'm a co-founder for Polymer Labs, and at Polymer, we're building multi-chain infrastructure, specifically by scaling IBC to all other chains.
Nice. And now, as we are like deeper into the bridging topic now, I just want to reflect on the past of bridging in the early days. So, in a nutshell, bridging in the early days was slow, centralized, and insecure. I remember when I first used the bridge between XDAI and Ethereum, it took like almost a day to bring my assets to another chain. So could we elaborate on this for a second? So why was it so complicated to bridge your assets from one chain to another just after the DeFi summer hype of 2020? Maybe you want to start about this.
I mean, yeah, so I think first of all, like we all sort of understand now that validator-based bridges need a lot of additional like security guarantees on top if we're going to actually trust them. They should probably also have economic security associated with them. Most validator-based bridges at the moment do not have that. So there's just operating, knowing that the risk that could get wrecked is like one piece, and you think that you'd also have a solid user experience with those risks in mind, but the user experience is also shit. So I think we still have a lot to go for bridging. I do think that some of the new interfaces for bridging, Nomad and Connext, have really provided a solid UX for allowing someone to move from one chain to the next, but also, of course, the model that, for instance, Nomad has, there is delays associated with that, but of course that's like ensuring security. So I think that at the end of the day, we're going to have to make some sort of compromise, whether it's UX, whether it's speed, whether it's security, and hopefully more bridges can basically sit in the middle. And that's obviously why we're so fascinated and excited by IBC. So I think over time, we will see kind of not only applications providing better user experiences for these bridges, but also the bridges themselves hopefully will evolve to like compromise across this like trilemma, which that's the real trilemma in my opinion.
We always have trilemmas in crypto, right? But you mentioned IBC, and It's actually pretty interesting because for me it feels like IBC is super old, but it's just 1.5 years old since it was shipped. Kim, you guys are working on IBC, and it unleashes really the true power of the Cosmos ecosystem because I can use everything so smoothly without interacting with a bridge. So could you elaborate maybe a little bit more on the power, the true power that IBC brings to us?
Yeah, definitely. I think, to your point about the history of bridging, when you think about it, starting in 2017 is when there were all these ICOs for like Thorchain or Ren, which were what I call interoperability 1.0 for bridging. Cosmos, IBC being a year and a half, I think there's been, it's really the most battle-tested solution out there for bridging, but right now it only exists within Cosmos. That's why we're so excited about our partnership with Composable, building IBC integrations with Polkadot to enable substrate-based interoperability with other chains, and also recently Composable had their proposal passed with Near Foundation as well. But ultimately, we think after surveying the interoperability landscape, IBC is the most advanced, most community-driven open source solution, and we think that that's very important to make sure that there's security. When you look at the past 3 years, I think the most pressing issue in the entire blockchain industry is bridging. It's over, I think, $2 billion in lost user funds, whether it's Poly Network or Thorchain or Ronin, Axia. All these different bridges have been drained, like Wormhole as well.
Yeah, speaking about that, I mean, if you just followed Rect News, most of these news were always about bridges. I think the chances that you were able to spot a bridging hack there was very, very high. So maybe if you could elaborate a little bit more how you are preventing these risks at Nomad, I think that would be interesting to know.
So most of these bridges are in essence multi-sigs. So there's a consortium of people that you trust that they will always do the message passing as they should. So if you send 10 USDC on one end, you will have 10 whatever USDC on the other. The problem is that if they have superpower, like they have root access, they have sudo to the network. So if they get hacked, then your funds are stolen, right? So in Nomad, as an optimistic system, even if the validator, like this special person in the system, gets hacked, it's impossible to have this kind of frauds. And the reason is because you have a watcher, as we call it, which is an agent of the system that looks over, and if it says fraud, it will freeze the system, basically. And that's why you have the lag, as you mentioned, is because we have to wait to see, was there fraud or that message is correct? In essence, instead of trusting a set of people, the system tells you, you should trust these validators, we move the power to the user and we allow the user to trust a watcher. So you will tell the user, you will choose who to trust. And if at least one honest player exists, then the system is safe. Of course, that has a lot of trade-offs. These bridges, they have a lot of good things. For example, they have speed. They're instant. They're simple, very easy to reason about. So I don't want to say that there is a silver bullet here. It's all about trade-offs.
Yeah, I agree with that. And what I find interesting is, like you mentioned this example, that they are basically companies that are handling my funds to send my assets from one chain to another chain. But we also see kind of a shift now. So you guys from Connext, you're also building on top of bridges now. So could you maybe talk a little bit about this? I think you also work with EVMOS. So we see kind of all these puzzle pieces together, and bridges itself become a playground in order to move capital between different chains. So could you maybe dive deeper here?
Yeah, totally. So I think, there's this concept of intra-cluster communication, which is where IBC sits, right? If you're in the middle of this ecosystem, this cluster of chains, then there are these native solutions for bridging, which are the best possible solution, right? Because IBC, it's incredibly secure. It's all light client verified. It's basically it solves this trilemma, essentially. But then when you get to these other types of zones, like if you're going between a Cosmos zone, you're going to like Ethereum rollup or something like that, then you don't have this kind of light client verification mechanism. So you need to do something else, and that's where you get to this sort of like an easy way of bridging, which is the easiest way is use a multi-sig. Or the easiest way really is to use like a centralized server. But then people are decentralizing that a bit by saying it's a multi-sig. Then you get into all these other trade-offs where you have to trust this group of people. So, you know, we really sat down, tried to figure out the best way to solve this problem. There's one thing you can do, which is an atomic swap, which is what Connext is currently based on. But then with that, the trade-off is that you don't have this kind of like generalizability to smart contract calls. And so that's when you get into these kinds of more clever systems. Like we found that Nomad pretty much is like the best solution for all these different trade-offs. And that's where we sit with Connext is we take our decentralized liquidity providers and we're going to plug into the best possible communication method between the chains that you want to bridge between.
Can I add that another solution for moving assets between chains is Coinbase? You could, in essence, like SX could be considered a bridge.
So to say, yes. But then, of course, there we have the trade-off that also Coinbase has kind of high fees. And again, it's super centralized. So, but yeah, theoretically, I agree with that. But yeah, let's talk a little bit more about IBC because it seems like that IBC is an all-in-one solution. You do not have this risk of centralization. It's pretty smooth, and I mean, the ICF worked very, very hard on it. And now we see that IBC is being shipped to other ecosystems as well. I think you know what I want to talk about now with NEAR. We saw this governance proposal coming up. Everybody's excited, so maybe you can share some insights, Alpha, with us.
Yeah, sure. I mean, so basically, I mean, I'm always going to conferences shilling IBC to other ecosystems, so I sound like a broken record at this point. But basically, like, I think for us, the IBC was architected with bringing it to other ecosystems from the beginning. And if an ecosystem doesn't have like client verification available, then it's like ETH2 will have this available, Solana does not have this available. So you can sort of see like that some chains just don't prioritize security. Other chains do prioritize security. And so I do think that over time, essentially most chains will be able to be connected via IBC. And so our recent progress is when we keep going to these different ecosystems, people initially get very like weird, obviously. So within Polkadot, obviously XCM is like the preferred communication standard. And so when we start talking about IBC, it makes people feel very uncomfortable. But I think you know, it really is just going to shape. It's already like, it's essentially the only interoperability standard that has processed as much volume with the rate of transactions as it has had to date. And we know that it can also be sort of 10x more than what's currently happening now. So when we go to people like NEAR, when we go to people like Polkadot, we sort of like have already a solid foundation to say, look, this is already working in production. Here are the changes that we need your protocol to make to be able to integrate with this interoperability standard. And that's where we sort of run into like a lot of technical conversations. Sometimes these things get pushed forth, like the NEAR stuff. Sometimes these things don't get pushed forth, and we have to end up resorting to like politics and other types of things to push things forward. But overall, I would say most people are pretty excited when we say we want to bring IBC to their ecosystem because they know that there's already a strong like TVL-based community, and like it's been tested for over a year now. So I think that's pretty valuable.
100%, and you touch base on something very, very interesting, like the wide adoption of IBC. I mean, for sure, if you are launching your Cosmos SDK chain, most of these chains have in mind already that they want to enable IBC. But we also have lots of existing chains with lots of liquidity, and I also remember a keynote held by Zeki at Avalanche Summit explaining how to ship IBC to Avalanche. And now, Peter, sorry, we talked about this before the conference started. So I was talking to a friend from Multichain, and he told me in a perfect world we would just have IBC, so to say. So what hinders us to bring IBC to every chain in the space? So what are the challenges that we have to overcome, generally speaking, to bring IBC to as many chains as possible?
I think honestly it comes down to technical overhead. Rahul mentioned that there's the categories of intra-cluster versus inter-cluster. I think currently IBC is intra-cluster, but IBC is just a specification. It's something that can be applied to all of their chains, which is our focus at Polymer. It could ultimately be inter-cluster. And to Brainjar's point, it's something that Composable and Polymer are both working to bring to all of their chains. Could you repeat the question? I feel like I said it.
Yeah, it's what are the precise challenges to overcome?
In terms of the technical overhead with Polymer, we're basically integrating light clients of every other chain onto Polymer, and with what we're calling a roll-up relayer, we're able to pass the data between our chain and the other chain. So Polymer is ultimately going to be this hub that connects Cosmos and non-Cosmos chains.
I mean, I just wanted to add really quickly, like, I was on a panel at OsmoCon with Sergey, and he said, for instance, connecting IBC to other ecosystems is really hard, and yeah, it's fucking hard. And I think it's hard because not only do you have to understand the IBC architecture and then fit it to a whole other ecosystem where IBC was not intended for, but also it's like very political. Like, proposals need to be passed, you need to speak to the right people, you need to have basically light clients on both sides, you have to have the relayer infrastructure to do so. So it's like a very like multi-party effort.
It would involve like a full hard fork of any network, right?
Yeah, essentially.
And I think at this point is like, again, coming back to silver bullets, like IBC has obviously some trade-offs of complexity. It's expensive. Like you can't implement a light client on Ethereum. You would have to go to a rollup. I think it's important to always keep in mind that it's a very complex protocol, which is obviously the end state. But
how would you imagine this end state precisely, and how far is it away from us?
I'm not as deep into IBC, so I wouldn't be able to say how the end state would look like or when. I mean, ask an engineer for a timeline and then double it. I think obviously having light client verification, it's instant, it's trustless, etc. But in essence, I have personally, that's my personal like engineering personality, that I have a fear for very complex solutions. And I think if things have shown like the past is that more simple things that may be more simplistic in some terms or 80% there usually are more successful because blockchains are like intrinsically very complex systems. We have a very complex distributed system in itself, and then we're trying to do more complexity.
So it seems to me like the end state would be like every chain validates every other chain possible. So that would mean like essentially the node overhead like multiplies or goes like m to the n power or whatever. So it just seems like that's going to be really hard, especially on like something like Ethereum, which is kind of trying to prioritize extremely light validator nodes. Like I don't really see how it would be possible to make Ethereum light client or like Ethereum light validator nodes that are running on like a Raspberry Pi validate literally every other blockchain in the universe. So that seems to me like where you'll run into kinds of issues.
I tend to disagree. I think that it wouldn't be every chain verifying transactions on every other chain. It'd be more like a hub and spoke model where one chain, like Polymer chain, will verify transactions on other chains. And what we've been dedicating a lot of resources to is ZK IBC research, where we can prove the light client verifications that Polymer conducts and post that information to other chains as well. I think the end state ultimately is all chains connected by IBC, IBC being the open source standard. And I think the most important part about that is that when you look at all these other exploits that I had mentioned earlier with interoperability 1.0, is that they were all their own unique designs and implementations of bridges. And hackers and exploiters, they went through and found flaws in those. But if it had been one open source standard and there was a larger community of white hats or just builders that looked at that and gave their own feedback and improved it together, then there would likely have been less exploits.
I fully agree with the vision, of course. I also think that there is a world in which, we essentially want the future to be focused more around passing data securely as opposed to passing assets. And so I think it's also like important from the application layer for developers to actually understand, let's actually start using cross-chain stuff for something more complex than just like cross-chain dexes or just simple token transfers or just cross-chain NFTs. You see a lot of these interesting new use cases sort of being talked about, but I think the vision of all of our cross-chain projects of what the use cases should be versus what's actually getting built is a huge gap, and trying to actually bring people to this level of understanding of what does it mean to go cross-chain, what does it mean to have additional market efficiency because of going cross-chain. These things are just barely scraping the surface. So I think long-term, something like IBC is going to dominate the ecosystem, because I for sure don't see a world in which validator-based bridges exist after 2 to 3 years. But I think thereafter, there is definitely a role in which IBC essentially becomes the sole kind of interoperability standard.
Yeah, and I totally agree with you also about this vision. And I would also say that the aspect that you mentioned, that we didn't scratch the surface, is not in a so distant future, actually. We see Mars Protocol, for example, basically combining the best out of Aave and Ume by deploying their protocol on different chains, but still having their own chain. Everything is connected with IBC. People can also take advantage of arbitrage opportunities, let's say on Juno, while they spotted it on another chain. So we slowly but steadily see the first puzzle pieces coming together, and this is also how we started this conversation. IBC is not that old, and we see so much progress already after 1.5 years, which is insane if you think about this. We are a little bit behind schedule, so I would take the first question. So are there any questions from the audience?
Thank you. Within the Cosmos ecosystem, there is Axelar that is building cross-chain communication. How this is integrated in the whole ecosystem? Is it different from IBC? Is it working with IBC? Sorry for the technical question.
To my knowledge, it seems as though they have, for chains where there is an IBC, they have essentially a validator-based bridge, and essentially where there is IBC, they have a wrapper plus a bridge fee. That's what it seems like to me. Maybe I'm wrong.
Actually, one of our earlier designs at Polymer was similar to what Axelar designed, but I think what Axelar, I believe, does use IBC, but they also have their own, what they call CGP, Cross-Chain Gateway Protocol. We think that ultimately that adds user friction for developers. If developers want to build in multiple chains, right now, with what we're building, they would just have to understand how IBC works. With what Axelar is building, you would have to understand how IBC works and also how CGP works. And to add on to the point I made earlier, you're adding an extra layer of design and implementation that loses the network effects of having multiple eyes on it for improved security.
Yeah, it's basically like a vendor lock-in type situation, right? So you have to build specifically for Axelar, which is an issue, versus an open protocol like IBC.
This is actually one of the main reasons why we also decided to push IBC as well, because it makes absolutely no sense to reinvent the wheel. It just...
Thank you.
So, I think this was a very interesting discussion and a very important one. And yeah, I hope that we see more and more network effects coming out of IBC. And yeah, EXA is actually also a very good point here. This was it. Thank you so much for attending this panel. I just see Sunny entering the room. So you're the next speaker, so you can immediately come here actually. So big applause please for Peter, for
Thank you.
Rahul, Omar.
Thanks so much, Juri.
Thanks, guys.